Hi guys, welcome to my channel Learning with Sarita. In this session, we will discuss electric field and important aspects of electric field. We consider a source point charge Q and Q naught test charge separated by a distance R. Now, the electric field at the point P at a distance R from the point charge Q is defined as the force that is experienced by unit positive charge placed at the point P and is given by E vector is equal to force by charge and is equal to F vector by Q naught. We all know that F vector is equal to K Q naught by R square into R unit, and we substitute F vector in the place of F vector by Q naught. Here Q naught gets cancelled and E vector is equal to KQ by R square R unit. That is equal to 1 by 4 pi epsilon naught KQ by R square into R unit. Here we know that R unit is the unit vector pointing from Q to the point P, and E vector is a vector quantity and unit of E vector is Newton per Coulomb, or we can write NC minus 1. Guys, I hope that you all followed the definition of electric field easily, and now we will discuss important aspects of electric field. 7 important aspects of electric field are to be discussed. They are direction of electric field, Coulomb's law in terms of electric field, dependence of electric field on source charge Q, dependence of electric field with distance, electric field independent on test charge, electric field for continuous and finite size charge distributions, and types of electric field. Let us discuss one by one, and now we move on to the first aspect, direction of electric field. First, we consider the positive charge. Guys, do you have any idea of direction of electric field lines in a positive charge? Yes, your ideas are right. In a positive charge, the electric field lines are radially outwards. Here, radially outwards means divergence from center and develop uniformly around center. That is, from a positive source charge, the electric field lines points away from Q. Now we will see what will be the direction of electric field lines for a negative charge. Here, in the negative charge, the electric field lines are radially inwards. That is, for a negative charge, the electric field lines points inwards towards Q. Guys, I hope that you all will have a clear understanding of direction of electric field lines. Now we move on to second aspect. The second aspect is Coulomb's force in terms of electric field. Here we find an expression relating Coulomb force F vector and electric field E vector. And let Q be the source charge, Q naught be the test charge placed at the point P, and E vector be the electric field created by the source charge. Now Coulomb force can be written as F vector is equal to Q naught by R square R unit. And here this can be written as F vector is equal to Q naught into KQ by R square into R unit. We know that KQ by R square R unit is nothing but electric field E vector. Now we replace it by E vector. Then F vector will be equal to Q naught into E vector. That is, Coulomb force is equal to Q naught into electric field. This expression gives Coulomb force F vector in terms of electric field. Now we move on to third aspect, dependence of electric field on source charge Q. Guys, you all know magnitude of source charge will be larger and the source charge creates the electric field. And so the strength of electric field depends on source charge Q and not on test charge Q naught. From the expression for electric field, E vector is equal to kq by r square r unit. It is clearly understood that electric field depends on source charge Q only. Okay guys, now we move on to fourth aspect, dependence of electric field with distance. Guys, you all know that electric field is a vector quantity, that is it has both magnitude and direction. The electric field intensity or electric field E vector created by source charge Q is inversely related to the square of the distance from the charge. We know that E vector is equal to kq by r square r unit. That is E vector is inversely related to r square, inversely proportional to square of distance. It is clear that as distance increases, the electric field decreases in magnitude. Now consider a positive source charge and its field lines are pointing radially outwards. Here the strength or magnitude of electric field at point P is stronger than the strength of electric field at Q and R. Now we consider a negative source charge and its field lines are pointing inwards. Here the magnitude of electric field which are nearer to the source charge will be stronger than the strength of E vector far away from the source charge. Now we move on to the next aspect, electric field independent on test charge. Guys, is electric field independent on test charge? Yes, electric field does not depend on test charge. From the expression E vector is equal to kq by r square r unit, it is clearly understood that E vector depends on Q and not on Q naught. And 2, the test charge is very small. It will not create any effect on source charge. That is, it will not move the source charge. And it will not modify the electric field created by the source charge. That is, it will not disturb the field of source charge. Okay, now we move on to the next aspect, electric field for continuous and finite size distribution. Guys, so far we learnt about point charge. Here we find E vector for continuous and finite size charge distribution. In a continuous and finite size charge distribution, there will be infinite number of charges and closely packed with no space between them. And for continuous and finite size charge distributions, integration techniques should be applied. And if the test charge is far away from the finite source, that is the sources of finite, and the test charge is far away from it, approximation methods can be used. Okay guys, now we move on to the next aspect, the types of electric field. Electric field are of two kinds, uniform electric field and non-uniform electric field. In uniform electric field, the value of electric field at every point in a region will be equal. And in non-uniform electric field, the value of electric field at every point in a region will not be equal. It varies. In uniform electric field, the electric field has same magnitude and same direction everywhere in a given space. But in non-uniform electric field, either magnitude or direction or both change in a given space. Okay guys, so far we have discussed the 7 aspects of electric field. In the last part of this session, we will discuss whether the electric field of a point charge is uniform or non-uniform. the electric field of a point charge is uniform or non-uniform. From the expression for electric field, we know that E vector is inversely related to square of R square. That is, electric field due to point charge is inversely proportional to distance from the source charge. So that at different distances, the value of electric field will be different. So it is clear that electric field due to a point charge is not uniform. Okay guys, I hope you all followed me. After listening to this video, you take your note and just recollect the points. It will be very helpful in your studies. Thank you.